Let's explore the world of edge computing and how it interacts with databases. We'll focus on database solutions designed specifically for these edge environments. You will learn database solutions for edge environments. Edge computing is a method where data processing and storage are brought closer to the sources of data. Instead of relying on a centralized cloud infrastructure, the processing happens at or near the edge of the network. You can see in the diagram the flow of data between the edge devices, edge servers, and the cloud. Edge computing offers several key advantages. First, it provides low latency by processing data closer to its source, resulting in faster response times. Second, it enhances security by keeping sensitive data local, reducing the risk of exposure. Third, it improves bandwidth efficiency by processing data locally, minimizing the amount of data transmitted to the cloud. Finally, it allows for offline operation, enabling functionality even during network disruptions. Operating databases at the edge presents unique challenges. One major issue is resource constraints, including limited CPU, memory, and storage capacity, as well as power consumption limitations. Another significant challenge is connectivity issues, such as intermittent network connectivity, complex data synchronization requirements, and the need to resolve conflicts. To address the challenges of edge computing, various database solutions are available. These include embedded databases, which are lightweight databases that run within applications. Distributed databases, which handle replication and synchronization across edge nodes. In-memory databases, which provide ultra-fast access for real-time processing needs. Mobile databases, which are optimized for mobile devices and Internet of Things applications. Effective data synchronization is crucial in edge computing. Two common patterns are bidirectional synchronization and push-only synchronization. Bidirectional synchronization involves a two-way data flow between the edge and the cloud, with built-in conflict resolution mechanisms. Push-only synchronization involves edge devices pushing data to a central cloud repository. Consider an Internet of Things sensor network scenario, where industrial sensors collect data locally using SQLite and periodically synchronize with a cloud database. In this Python code example, the Edge Data Handler class manages data storage on the edge and handles the synchronization process with the cloud. To summarize, edge computing brings data processing closer to reduce latency and improve performance. Choose lightweight databases optimized for resource-constrained environments. Implement robust synchronization strategies to handle intermittent connectivity. Edge databases enable real-time processing while maintaining data consistency across distributed systems. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.